Hello, and welcome to the Physics of Lacrosse podcast. Speaking today is Thomas Carlock, Duncan Jackson, and with the additional help of William Flynn. Please enjoy learning about the physics of lacrosse.
The physics of lacrosse includes the concepts of momentum, levers, friction and tension, potential and kinetic energy, axis of rotation, accuracy, and precision.
Additionally, the Newton's laws of motion applies to lacrosse.
In this clip and the following, accuracy is used to aim and hit the lacrosse goal.
In this clip, the lacrosse player uses rotational momentum in order to gather energy behind the ball and then propel it forwards. This allows him to shoot the ball at high velocity.
Alright, go.
In this clip, you see the lacrosse player gather potential energy in his leading foot and convert it into kinetic energy by bringing the lacrosse stick over his shoulder, thus propelling the ball forward.
By doing this, he gathers the most momentum on the ball.
Go. Go.
In Newton's second law of motion, acceleration is produced when a force acts on a mass. So we can calculate the force of a stick on a lacrosse ball in a pass or shot by taking the mass of a stick multiplied by the acceleration of the stick. Also, we can calculate the force of a moving ball in the air by taking the mass of the ball and multiplying it to the acceleration of the ball. In this clip, we used a .145 kilogram lacrosse ball accelerating at 10 meters a second and found the force of the lacrosse ball is 1.45 newtons.
Go.
When passing or shooting a lacrosse ball, torque, rotational energy, kinetic energy, and momentum all affect the type of pass or shot by an offensive player. As the ball is traveling through the air, like all other sports, it follows a projectile motion pattern. Projectile motion is where a particle, the lacrosse ball, is thrown near the Earth's surface and it moves along a curved path under the influence of gravity.
Go.
In these clips, the lacrosse player has shown how accuracy is used in the game. We had him hit the top right corner of the cage 5 times. In doing so, he hit 4 out of the 5.
The farther an object is from its axis of rotation, the faster its speed is. His arms and stick act as a series of levers to propel the ball forward. As Duncan drives his foot into the turf, the friction against the ground allows him to convert his linear momentum into rotational momentum. Cradling a lacrosse ball is crucial to the success of a great lacrosse player. This is where technique and form are essential parts of the game. Cradling is where a player twists his wrist and forearm to keep the ball inside of the lacrosse head, otherwise known as centripetal force. Also, friction from the pocket and the mesh of the head help hold the ball in place. Therefore, cradling is critical to the success of a player to dodge and keep the ball at all times.
Go.
Newton's third law states for every action, there is an equal and opposite reaction. When catching a lacrosse ball, the force from the ball in the air hits the mesh inside the lacrosse's head. Then an equal and opposite force occurs against the ball from the mesh in the head of the lacrosse stick. To counteract this equal and opposite force, the player will slowly move the head of the lacrosse stick away from the direction of the lacrosse ball to make a smooth, easily catchable lacrosse ball. This is the height comparison of Duncan and the lacrosse stick. And this is the goal that we are shooting on.
The head of the lacrosse stick plays a major role in how the ball comes out of the stick as a pass or shot. Shooting strings are weaved in and out of the mesh, giving the ball different spins and speeds. At the beginning of a pass or shot, the friction from the shooting strings and mesh turn the outward force of the ball into angular motion. As the kinetic energy and force move up the shaft of the head, the mesh stretches around the ball, creating elastic energy. This also increases the speed of the lacrosse ball as it flies from the release point of the lacrosse head.
In the beginning of the video, the lacrosse player was shooting at the top right corner of the cage. While shooting, this is what we gauge as the top right corner in order to prove accuracy.
Right here, I'll demonstrate the lever.
For your enjoyment, here are some bloopers of a very inexperienced lacrosse player trying to throw for the first time.
Whatever.
You don't have to record anymore.
Once again, my arms will demonstrate lever.
Why you gotta say something? Keep going. You're doing well.
Oh.